Hi, all. We're going to give just another minute or two for everybody to get logged on to the webinar. But while you're waiting, you can take a stab at today's trivia question there. We'll answer it when we get started. But we're just going to give it another minute too to make sure everybody's on. All right, I guess we'll get started. We have a lot to cover today. So welcome to the Energy and Waste Reduction through Continuous Improvement webinar. My name is Jen Jones. I am a PennTAP technical advisor, and I'm going to be your host today. Before we begin, let's just take a hot minute to answer today's trivia question. So when was the term lean production first used? If you answered C, 1990, you are correct. The term was first used in the book, The Machine That Changed the World, and was written by Womack, Jones, and Roods. And this book was the first to describe the principles of lean and how Toyota used them to become the largest automaker in the world. Before we get started, I have just a few quick items of business to cover. If you're having any technical difficulties whatsoever, if it's accessing or hearing the presentation, please use the chat pad and we'll try to correct them promptly. Today's presentation should last about 40 to 50 minutes, and that'll be followed by a 10-minute question and answer period. Please, we will wait to answer any specific questions until that time to allow us to move through the material efficiently. And if you have any questions after the webinar is over, please send them to us via the email, PennTAP's email, which is penntap@psu.edu. This webinar is being recorded and will also be uploaded on the PennTAP website at a later date, and you will receive a follow-up email to let you know when it is available. So during today's webinar, I will discuss continuous improvement or lean manufacturing as a means to reduce energy consumption and reduce pollution at your facility. We will discuss one of PennTAP's services known as the E3 assessment, which couples continuous improvement or lean manufacturing with energy conservation and pollution reduction. I also have a continuous improvement coach from the IMC with me today, Jeff Kopenitz. And he's going to provide you with a high-level description of the value stream mapping process and share success stories from recent projects. So Jeff, thank you so much for joining us today. And we will then conclude with a short overview of PennTAP and the other services we have to offer. So let's get started. I'm sure most of you are familiar with the terms continuous improvement and lean manufacturing. I would like to take a moment, though, to define these terms and how we are going to be using them today. So continuous improvement is the practice of evaluating an established process to identify ways in which it could be improved. Problematic areas within the process are identified and include issues such as downtime, product rework, or production bottlenecks, to name a few. And potential solutions are identified and then implemented to determine what is successful and what is not. Lean manufacturing focuses on eliminating waste in the production process. Again, potential solutions are identified and then implemented. There are those who hear the term lean and instantly think layoffs, and I cannot stress enough that this is not always the case. In fact, lean can create or retain jobs as it helps to eliminate extraneous costs within your process. I would also argue that these terms can be used interchangeably, as eliminating downtime and bottlenecks within a process tends to result in waste reduction. Therefore, lean manufacturing and continuous improvement go hand in hand. And in today's webinar, we will be using these terms interchangeably. Continuous improvement projects will allow you to use your equipment more efficiently. Believe it or not, product rework, downtime, bottlenecks, these all cause you to run your equipment more than is necessary and increase the energy consumption and costs at your facility. It will also lead to higher maintenance costs and can decrease the life of your equipment. For example, I was at a bottling plant where consistent issues at the filler station and frequent product changeovers resulted in frequent stops and starts along the conveyor line, and equipment such as the bottle washer was running when no product was going through. Constant starts and stops caused wear on the motors, which frequently broke down, temporarily halting production while repairs were completed. Wear decreases a motor's operating efficiency, which also leads to increased energy consumption and costs. Also keep in mind that inefficient production can lead to unnecessary overtime hours to meet your customer demand. This means that all equipment, including your lights, your forklifts, are in use during the duration of the overtime shift and are also consuming energy. According to the Environmental Protection Agency, the average cost to treat or dispose of waste is about $2.09 per pound. Continuous improvement projects often result in waste reductions, decreased water consumption, and reduced use of hazardous materials. So let's think about this. How many of you out there are generating scrap in your process that cannot be reworked and must be disposed of? Believe it or not, a continuous improvement project will help you to identify why this is occurring and identify possible solutions to remedy the issue. Sometimes eliminating waste is as simple as changing your production schedule. So remember that bottling plant I just spoke of? A production schedule was suggested that will minimize the wastewater generated during production. As a result, the facility is expected to save over 263 gallons of water annually, which was equivalent to a cost savings of about $5,780 per year. Lean projects can also identify areas where hazardous waste can be reduced. If you're having issues with contamination in your finishing solutions that result in rework, you may want to consider mechanically pre-cleaning the parts prior to finishing, which reduces the contaminants entering those solutions. This will not only prolong the use of these solutions, but will also reduce the hazardous waste generated at your site. And don't forget, a simple switch from toxic chemicals to safer or green alternatives can also decrease the waste generated at your facility. There are several non-toxic cleaners and degreasers and other alternatives to any other toxic chemical that may be in use at your plant. And these are all available through the EPA's Safer Choice website. So one of our most popular services here at PennTAP is the Energy, Economy, and Environment, or E3 assessment. Historically, we have focused E3s on food and metal manufacturing, but we will consider other industries on a case-by-case basis. During the E3 assessment, PennTAP, a continuous improvement coach from your local industrial resource center, and a team from your company work to identify one process or product family to be evaluated. Prior to the E3 assessment, PennTAP will determine your baseline energy and water consumption, and then complete an operational assessment at your facility. This is then followed by the E3 event, which is led by a continuous improvement coach. During the event, lean principles will be used to create a value stream map that identifies areas of downtime and waste. Typically, these areas also represent an opportunity to reduce energy consumption, pollution, water consumption, and hazardous waste. The E3 typically takes about 4 days, but keep in mind, it doesn't have to be 4 consecutive days. We always strive to schedule these assessments in a manner that will fit your needs whenever possible. Over the past 5 years, the E3 assessments have helped Pennsylvania manufacturers reduce direct and indirect air emissions by more than 4,700,000 pounds per year, CO2 emissions by over 1,000 tons per year, non-hazardous waste by more than 12,600,000 pounds per year, water consumption and wastewater discharged by 12 million gallons per year. It's decreased natural gas consumption by 805 million British thermal units per year, and electricity consumption by more than 4,500,000 kilowatt hours per year. At this time, I would like to introduce Jeff Kopenitz, a continuous improvement coach with the Innovative Manufacturer Center. I've worked with Jeff during several E3 assessments, and he's going to walk us through the VSM portion of the E3 event. So Jeff, I'm going to turn it over to you.
All right, great. Well, thank you so much, Jen, for that introduction and that overview of what the E3, the purpose of it is, and kind of how we do it. If you can kind of go to the next slide. All right, next. Just a little bit of background here on value stream mapping. Value stream mapping was introduced through a book by the name of Learning to See. In 2019, it marked the 20th anniversary. I remember back in '99 when I got the book Learning to See, and it's written by a great guy by the name of Mike Rother. And he introduced it through a case study in what value stream mapping is and how to do it, and kind of the purpose of it. Next. The real purpose of value stream mapping here, folks, is really to understand what is basically happening in our current state and developing a future state, providing direction. All right, and I say that very passionately, providing direction. Where and what do we need to work towards? So mapping uncovers many of the obstacles that lie between a desired state of where we want to be, but really we need to understand where are we today. And value stream mapping is just a great tool. I love to call it, it's like taking an X-ray of the business and trying to diagnose what's happening today and providing us a direction of where we would like to go. So it really identifies a lot of new opportunities for improvement, and I would say challenging the organization to move forward. Next. I'd like to start off with our improvement model. And in this model here, folks, is sometimes we refer to as the improvement kata, okay, kata being a pattern of improvement. But in this model here, you'll see 4 steps. And step number 1, and this is where we use value stream mapping, is understanding the direction or understanding the challenge. And that's what we really like to utilize in understanding where are we trying to go? Where does the business need to go? Once we understand that in the direction of where we're heading, now we need to jump down to call it step number 2, which is grasping the current condition and understanding what is happening here today. So when we have a good understanding of the current condition or the current state, we understand where we need to go. We then ask ourselves, well, where do we want to go next? And that is in step number 3, in establishing what we call our target condition, the first target condition. And we typically use a timeline. I try to keep these rather short. I'm saying, where do you want to be 5 days to 30 days out? And that is the first step. Knowing that going from step 2 to step 1 is a long work, a long period of time, maybe a year, year and a half, 2 years out. I typically go a year out, but we take this in small increments through target conditions set 5 days to 30 days. Once we've set that target condition, now what we need to do is to start to identify, well, what's in the way there. And that's where we get into step number 4. And we are identifying, call it obstacles that are in the way. And what we do is we start to work through those obstacles with our classic PDCA cycles. So that's basically the improvement model. And we utilize, I'm going to say, this model when we're doing some E3 work with our clients. Next. So let's get a little clarification here. What is a value stream? Okay, a value stream is all of the steps, including value, non-value, that lie within call it a value stream. In this particular case, I have a process, and Jen, if you could kind of hit the next button, a value stream, or all the steps, both value, non-value, required to bring a product from raw material to customer. And that is what we call a value stream. It could cut across departments. In this particular value stream here, we see that we go from stamping to welding to assembly. That's a value stream from raw material to finished product into the hands of the customer. Next. Typical mapping steps starts with preparation. And typically in our E3s, what we do is we will have a few phone calls or Zoom calls with a client, and just preparing them, asking them what value stream would they like to consider. And we talk about timing and how big, how small. And once the actual, say, event happens, we then go and we start to walk the value stream. Actually going into the value stream, asking, observing what should be happening, what is happening. Once we do that, we start to document it. And when we bring that documentation in, we start to analyze it. We start to, through that analyzing, we then design a future state map. And then we develop a challenge from that gap. And we start working towards that first target condition. And we actually start to experiment towards those target conditions. Next. Here's a classic value stream map, a typical current states. And you can go ahead and hit, and what you'll see, keep going, Jen. Keep going. Keep going. You got it. All right. Thank you. As you'll see here, this is a classic value stream map. Some people call it a process map. It's a little bit higher level of a process map. But what we're actually doing is we're going out and we're watching, we're observing, we're questioning, and we have metrics wrapped around the various different process steps there. In this particular case, I circled the high levels of inventory here. And what this map, what we walked away with through some of the metrics was it consumed over 24 days of lead time to get a product through. And the actual production time was a little less than 3 minutes, or a little over 3 minutes. And that was the current condition. This is classically what we see. Next. And then what we start to do, we analyze that future state map, or that current state map, and we start to put together a vision of the future state. And as you can see here, this is what that future state would look like for that previous current condition. And we start working now towards this future state, utilizing a set of questions, classic questions of things such as how fast do I need to work? What known as the tack time. Are we going to build to finished goods? Or are we going to build to shop orders? Where can we have continuous flow? Where do we need to schedule? How can we level load? These are all typical, call it obstacles, folks, that are in the current condition that we don't see And what we're trying to rid the non-value, the waste out of the process and build a future state so that we can work towards this future state. Next. And again, these were just some of the questions that we saw. Here's some examples here that I'd like to share with you. So the background of this organization, and Jen and I did this one together. They were celebrating 10 years of operation. The organization was grown from about 10 employees to approximately 90 at the time. The growth had fueled a real backlog in their work. And the backlog was on a particular value stream that we were evaluating. The current lack of flow from what we saw was impacting the daily number of units being able to produce. And the overall, I would say, challenge that was facing this organization was that by April 1st, 2022, the organization would like to produce 30 plus widgets per day with 8 associates on line 1, 2, 3, while maintaining a safe work environment. And once we created that challenge statement, making some observations, kind of our rally cry, meaning that a common plea that everybody kind of in the shop would understand was having the right parts in the right place at the right time. Next. So the scope of this particular E3, this value stream, the scope was from the value stream mapping was followed from the material being received and stored, followed by the fabrication of components and delivery of components to line 1, 2, 3. And then line 1, 2, 3 performs various metal tasks. And then they hand that to and through a paint system. So that was kind of the scope from fabrication through the line 1, 2, 3, all the way through paint of the value stream map. Next. And here's what we found in the current condition. The current condition in the map that we created. We found by walking the value stream that raw materials to fabrication were stored in a wide variety of different areas. The currently producing approximately 15 to 20 units per day with a cycle time of about 26 minutes. Materials and product traveled approximately 0.3 of a mile per unit. Each unit was picked up and put down approximately 14 times. And each unit incurred approximately 18 minutes of material handling and loss of approximately 9 man-hours per day due to missing or wrong parts being made. And the first pass yield in this current situation was around 37%. 37% of a chance of a unit making its way through the actual value stream without stopping. There was a daily department schedule that was not known by associates and misalignment of department A schedule with the actual line number 1, 2, 3. So that was when we walked it and observed it, as well as looking at some of the energy and the impact and the environmental things that we found. This was from, call it, the efficiency side of the value stream. Next. So once we documented it, we then started to do some analysis. And what we found was with the available time that they had, they were currently running 9 hours per day. And the customer demand that we were shooting for was 30 units. We needed to have a unit out every 18 minutes. That was kind of the rhythm that the line needed to run at. And if you remember, through that current state, we were running at around a 26 minutes per unit. So to meet the organizational challenge, the team had to run at a rate of every 18 minutes, a unit was rolling out of paint. And the team would work towards a planned cycle time. We wanted to run at around 15 minutes. Next. So we furthered our analysis and we did your classic cause and effect diagram here, not able to meet a 15-minute unit cycle. What was getting in the way? What were some of the obstacles in the way? And we looked at it through the lens of the machine, the equipment capability, the people capability. From a machine perspective, we had some pressure issues, poor flow between machines in a particular department, new hires coming in and their capabilities were being questioned, or the training was being questioned, product being pushed versus being pulled through the system, the scheduling alignment, as mentioned earlier, movement of materials, no standard fixturing to help, work in process storage. So these were things that, and this was not just call it Jen and I doing this. We had team members from the line working with us to help generate this. Next. With that said, we then went ahead and we built our future states. Okay, with our future states, along with the team, in our future state aligned to say what we outlined earlier, a planned cycle time of 15 minutes from the current state of 26 minutes. We were really eyeing up the 80%, increasing the first pass yield from that 37.1%, trying to get it up to 80%. And we went ahead and said, we got to start reducing the actual travel time. We trying to almost go to a 50% reduction there. And we threw out there, not threw out there, but I want to say strategically designed it to get it down to about 0.16 miles versus the close to over 310. So about a 50% reduction there. That was our kind of our future vision. All right, so next. So now that we had a defined challenge and a good understanding, you can go ahead and go through the animation. Okay, there we had the challenge, we had the current state. Where do we want to be next? And we established our first target condition. All right, so we created the current state, or the challenge statement, the current state, where we are. Now, where do we want to be next? We observed, I would say, just some of the things that we felt were preventing us from that 15-minute planned cycle time. The first target condition here, folks, was we needed to align Department A schedule with line 1, 2, 3 schedule, so that the right parts are being made in line 1, 2, 3 does not run out of parts by 11/24/2021. That was our first where we needed to be next. And we identified some of the obstacles to that first condition. As you can see here, the visibility of the schedule, not known by the operators, therefore incorrect parts were being made. We also noted that new operators were not capable of making parts in fabrication. We also said the correct material to parts not available. We also mentioned that presentation of parts not for the line was not standardized. A lot of searching, space for small parts, and we needed to communicate across the departments. And another one that was in the way of that first target condition was the equipment capability. So that first target condition, anything that you saw highlighted in red, were the things that we went and we identified as being obstacles. We said, okay, we have obstacles. Now what do we need to do? Next. Well, what did we do? We started to run PDCA cycles, Plan D Check X cycles. Our focus was on the visibility of the daily schedule. And the target condition there was to create the schedule to be aligned in Department A, to be aligned with Department 1, 2, 3. And the obstacle was the visibility of the schedule. And our first step, the first step that we wanted to do was to post whiteboards at each station, at each machine, indicating the daily schedule in 4-hour increments. We needed to be able to tell the actual associates, the subject matter experts, the people running this equipment, what was due, what was expected. At this point in time, they didn't know. So what we expected was that the operators were now being communicated to, and a schedule is being, I would say, adhered to on a daily basis. And that was what our expectation was, that we would see a schedule and the schedule was being filled. What happened? On the first day, we didn't have it, I would say, ready for the guys in that area, and they played catch up all day long. You know, it wasn't, I'm going to say, dispersed amongst all the equipment. And what did they learn from it? Well, they needed to have it completed the night before. And what I mean by that was that the schedule wasn't ready. So the next morning they were playing catch up. So what did they do? Based on what we learned from that experiment, we ran another experiment. And that experiment, the expectation of when the line should be done was explained. And now the operators, what we were explaining, or what we were expecting to see, was the schedule would be out there in 4-hour increments every day. What happened? It was completed, and an estimated increase of 50% took place. A 50% improvement was realized, that the right parts were being made and delivered at the right place. So operators will work if they know what was learned there. And these were, I'm going to say, experiments and learnings from the actual folks that were running these experiments. So what we basically did here, folks, was we experimented through these actual obstacles that we observed there. And after that one, we then created a small line sheet to communicate the actual needed schedule for the line. And say, moving forward, that became kind of the standard that the line was following and the fabrication department was feeding. Next. So the net results, okay, and folks, that was just one level of experimentations that we ran, one target condition that we ran to. Once we met that target condition, we set the next target condition. And that was where, I'm going to say, Jen and I and the team returned back. And that target condition was met, and we set the second target condition. And we repeated this cycle again of, okay, if that's where we need to be, what were the obstacles that we saw, and what were the obstacles in our way? And boy, oh boy, it really, we were working on the things that we needed to work on, not what we wanted or not what we could work on. Because this was painful for some of them. This was painful because they didn't know, okay, how to work through, how to put that level of expectation out there. The net results, okay, the net results, and these are words from the general manager, okay. We have seen a daily increase of anywhere from 25 to 30%. Some days, depending on the widget style, we see 40%. Since November 30th, 15 to 20 widgets daily to I would say, most recently, 35 to 40 widgets being built per day. And on another case that we performed we took the same approach from an E3 perspective. And these were the comments from this particular organization. We were able to go from about 18 to 22,000 gallons per day to 28 to 34,000 gallons per day, sometimes more. We are now hovering currently anywhere from 28,000 to 32,000 gallons per day consistently. So the same approach was taken by understanding what the challenge was, understanding the current condition, and incrementally working towards that challenge. And I can't overemphasize the importance of making it and calling it a challenge. And we call it a challenge because it should be uncomfortable. It should be something that we're saying, I'm not sure how we can get there. You got yourself a good challenge. All right. So that was the net results that we gained. Jen, I will hand it over to you.
Thanks, Jeff. That was really great. Before we move on, I would like to note that the case that Jeff kind of walked you through in this, all of the travel he talked about for the product was actually on forklifts. And so I just had a conversation with this client last week. Out of this E3, they were able to completely retire the use of one of their forklifts. And I think they, if my memory serves me, were using about 8 on site. So to completely eliminate the use of one forklift, just think of the dollar savings on maintenance, repairs, propane, and better utilizing that employee for a different position. So it's just amazing at the savings that can come out of these. So before we conclude, I am just going to tell you a little bit about the rest of our services here at PennTAP. PennTAP itself is a statewide technical assistance organization that's charged with supporting Pennsylvania businesses and anchor institutions, including manufacturers, municipalities, educational institutions, entrepreneurs, and economic development agencies. We began over 50 years ago as one of the first technical assistance programs in the country, and you can find us at pentap.psu.edu. We have a diverse staff with backgrounds in chemical engineering, electrical engineering, environmental science, management, and economics. And our staff includes a certified energy auditor, certified energy manager, registered environmental auditor, renewable energy professional. We have a professional geologist and a Six Sigma Green Belt on staff as well. In addition to our E3 assessments, we also offer pollution prevention and energy efficiency assessments that we also call P2 E2 assessments. This is where we help companies decrease pollution and increase energy efficiency in their overall facility. PennTAP is one of a small group of organizations that was recently selected by the U.S. Department of Energy to train a small cohort of manufacturers in their ISO 50001 Ready Navigator program. This pilot program enables companies to implement a tailored energy management system, which provides the framework to integrate energy efficiency into your existing management systems. We also offer Penn State graduates in the College of Engineering opportunities to gain hands-on experience by having them assist us with our energy assessments. These students often utilize the knowledge they're gaining in the classroom to bring new ideas to our clients. And beyond energy, we work closely with our clients to understand the full range of their business needs and facilitate innovation by creating connections back to the university and our vast network of resource partners located across the state. PennTAP can provide your business with no-cost and low-cost opportunities to engage with Penn State students, faculty, and facilities through internships, capstone courses, classroom projects, and even research partnerships. Penn State classroom projects and capstone courses provide a great opportunity for companies to tackle complex problems using classroom knowledge and world-renowned facilities. PennTAP has enabled connections to the university for a variety of industry-sponsored projects, including product development through prototyping at the Learning Factory, improved production flow through Six Sigma students in the industrial manufacturing engineering classroom, and growth into new markets with market research completed by the Smeal College of Business Nittany Lion Consulting Group. PennTAP has grant opportunities to offset the sponsorship fees for the Learning Factory, which would allow a select number of industry sponsors take advantage of this resource at a reduced cost. Before we conclude, I would like to tell you about our upcoming webinars. Join us again on March 17th for the Penn State University Engagement Opportunities for the Plastic Industry webinar. In this webinar, faculty and staff from Penn State Behrend, home of the largest academic plastics training lab in the nation, will share information about cutting-edge research, state-of-the-art facilities, academic programming, and continuing education for plastic workers and industry-university partnership opportunities. Join us again on April 21st for the Understanding Your Utility Bills and How It Can Save You Money, where we will discuss how to read your utility bills, provide insight into some common charges to watch out for, and share resources available to help you save money on your energy consumption. Both of these webinars will occur from 11 a.m. to 12 p.m. So today, if you take anything away from this webinar, I would like you to leave with the knowledge that continuous improvement projects result in decreased energy and water consumption, waste reductions, and reduced use of hazardous materials. The E3 assessment offered by PennTAP in conjunction with your local IRC couples continuous improvement or lean manufacturing with energy conservation and pollution prevention. And the value stream map provides direction for an organization in their improvement efforts. At this time, I would like to open the floor to questions, so please type any you have in the chat box and we will answer them to the best of our ability.
Hey, Jen.
Yeah.
This is Jeff again. One comment that I would like to make that I failed to say anything about. I think one of the big benefits that this client has realized in that first case study that we spoke about is that the belief by their employee, the engagement of their employees into making improvement has skyrocketed. All of the pain and I'll call it frustration that some of these employees were dealing with in their day-to-day, just trying to do their job. I don't want to say we totally eliminated, but they're now seeing, I'm going to say, some opportunities and seeing more because they're seeing things get improving and getting better. And he really kind of sheds the light on, hey, there's hope. So it really, really helps, again, grow the engagement. And I failed to say that, but I think we'd be remiss if we didn't truly mention how important that side of kind of the business is, our most important asset, that being our people.
I totally agree. And since we have some time, I think one of the favorite things on my end that came out of that assessment was there was one of the team members in the assessment really just began to shine. And I think you know who I'm talking about. Mm-hmm. And yeah. my favorite thing was day 2. He comes walking in with a piece of metal in his hand. And he is so excited to share this with everyone. Yeah. And so basically he holds it up and he goes, I have a question. Why do I weld this onto the widget and then weld the handle onto this? Mm-hmm. And nobody could answer it. So yeah. Out of all of this, got this employee thinking, why do I do what I do? And they totally eliminated that little piece of metal. And I mean, what was it? Like a 4-inch by 3-inch piece of metal that adds up all the time to cut it, all the time to weld it, all the materials came out of it. And from what I've been told since then is he's really taken a leadership role on that I don't know would have come out of this had he not been a part of this team.
Yeah.
So it totally attests to what Jeff is saying. Like we
Mhm.
really saw these employees come together as a team, and morale just seemed to improve
Right.
throughout the assessment.
Mhm. Yeah, it was kind of cool to see, by call it day number 3, that the engagement of those this key stakeholders being our associates, their associates, was really got involved. So it was nice to see.
Yeah. So does anybody have any questions? Somebody's got to have a question. Well, I guess if there's no, oh, there we go. So Landon is asking, he's very interested in to please explain the process going from today to having PennTAP on site. So, you can request our services through our website, pentap.psud.edu. I'm going to go to the next slide because my information's on the next slide. You can always contact me as well. And so how we would start it is we would have a call with you, and then find out a little bit about what you're looking for, and what project you're thinking of implemented, be it an E3 or an E2. If it's an E3, then we would probably have a second call where we want to tie in the IRC and discuss what product line you think you would like us to evaluate. In that interim, we will send you a pre-assessment form and request 1 year's worth of utility bills. If water is a major part of your process, we're going to ask for water bills. If you have a lot of hazardous waste, we might ask for some of those disposal bills as well. And then once we receive that back, we take a look through and we schedule your energy assessment. In general, the energy assessment will take about, depending on the size of your site, and if it's an E3, the size of the process or product family to be evaluated, they take anywhere from 4 to 5 hours, sometimes 3 if it's a smaller facility. And keep in mind, we do need somebody to walk us around while on site. We do that so that we're referring to the equipment as you would. You'd be surprised at what comes out in conversation as we're walking through. And then I like to take about 2 to 3 weeks to process all of that data if an E3 is going to follow. Every IRC does their E3 slightly differently. Keep that in mind. So your local IRC, the continuous improvement coach, may do it slightly differently than how Jeff's approach is. But when we work with Jeff, it tends to be, we like to do day 1 and 2 back to back, and then come back a couple days later to do day 3. At the end of day 2 is when Jeff starts giving you some of those experiments to try out, and we come back and listen to what worked for you, what didn't work for you. And keep in mind, it doesn't have to be that way. We can do it once a week. The idea, though, is to keep this assessment, the momentum moving. So I wouldn't recommend doing it at a greater distance than maybe 1 day a week, to be quite honest, just to keep people's thoughts going and like I said, the momentum doing. After that time, depending on how much we have done at that site, you can expect your report typically within an 8-week period. And then we follow up with you, routinely throughout. The IMC does as well. All of the IRCs do, to make sure you have no further questions, you have no further needs. I have clients that I talk to every single year or reach out to me. Hey, I'm looking for an intern. Hey, I'm having trouble with product development. Hey, we're thinking of upgrading a compressor. Are there grants? So I like to tell people, don't think you're done with us after we've come out once. And the IMC is very similar.
Mhm.
So I hope that answered your question. If you have a follow-up to that, don't hesitate to ask. Jeff, did you have anything you wanted to add to that? I should have asked you.
No, Jen, I think you pretty well covered it. We're here. If you have questions and you're considering, I just love the whole E3, I call it purpose, because you're really taking a holistic view of your value stream. Years ago, we just did our classic, cycle times, and your classic metrics, uptime, downtime, cycle times, inventory levels, things of that nature. But boy, oh boy, when you start looking at the entire impact of both the environmental side of it, as well as the electrical side, the energy side of it, it really opens up a lot of different eyes. I can't ever remember doing one that there wasn't significant savings, savings actual as well as even potential savings that were not uncovered. And this goes back, I think I did my first E3. I'm not good at dates, but I bet it was in 2007. I don't know when they actually started, but it was quite some time ago. The impact on that one was very significant as well. So needless to say, guys, I really, for those companies out there, don't overlook the opportunity. It's there. I highly recommend it.
Yeah. I think they're, out of the different assessments PennTAP does, I think they're my favorite. It's so interesting to see. And even, people don't know, to quote the client we're kind of highlighting through this, people don't know what they don't know.
Mm-hmm.
And you guys live that process every day. So
Yeah.
It's eye-opening when someone comes in and goes, have you thought of doing this? And, with that last client, a majority of, I think all of it, correct me if I'm wrong, Jeff, of the reduction in product travel was just storing at a point of use, as opposed to keeping it in the warehouse and driving it over on demand.
Mm-hmm.
It was something that simple that nobody thought of because they've lived that process every day.
Yeah.
So, I've had people say to me too that, oh, well, Lean, I don't want to reorganize my plant floor. We're not necessarily going to come in and tell you to do that. That actually rarely happens, to be honest.
Yeah.
And it's usually at the request of a client, if that's what is being looked at. It's how to live in the footprint you have and how to reduce that environmental footprint and your energy footprint, and utilize your employees in a better manner and your equipment.
Yeah.
So
good.
And Jeff does a great job of it. So I've worked with
thanks.
him on several projects. So I guess if there's no other questions, we will close it out for the day. Thank you for joining us. I greatly appreciate it. Again, I'm Jen Jones. I can be reached at 814-865-4542. My email is jsm148@psu.edu. And if you have any follow-up questions, please do not hesitate to reach out. And if you're interested in our services, you can either contact me or hop on our website and request. So Jeff, thank you again. You're one of the busiest people I know. So thank you so much for joining us today. We greatly appreciate it. You did, it was great.
Well, thanks for the opportunity, Jen. And I want to go right back at you. You do a phenomenal job, as well as Denise and any of the other PennTAP folks. They're a great resource there, folks. Utilize it. Okay, utilize it. So thanks again, and all of you have a great day.
Yep, thank you. Have a good afternoon.